This week, we bring you a special episode of Quality Digest live from the Nikon Metrology booth here at IMTS in Chicago.
That's right. We'll be looking at some great new manufacturing concepts and technologies, plus much more, when we come back.
Welcome back to Quality Digest Live for September 11th, 2014. QDL is your weekly look at who and what is making the news in the world of quality. I'm Mike Richmond, publisher of Quality Digest.
That's right, and I'm Quality Digest Editor-in-Chief, Dirk Ducharme. We start the show this week, well, naturally enough, with a report from IMTS, since that's where we're sitting.
Where we are.
This is the biennial gathering celebrating the technology of manufacturing. This has been another highly successful show with more than 100,000 registered attendees from around the world. Mike and myself and the rest of the Quality Digest team have walked all 4 floors, and let me tell you, it takes you about an hour and a half to walk from one end to the other.
I can vouch.
Yes. We've walked all 4 floors of the show this week. And seen as usual, lots of interesting new products and technologies, from the latest in test and measurement to a 3D printed car.
That's cool, yeah.
That's right. Mm-hmm. Of what we've seen at IMTS so far, and remember there are still 2 full days left after today, 2 things stand out, at least for me. The first is education and training within industry. Mm-hmm. Companies such as Hexagon and Zeiss and others recognize that they have to do a better job of grooming the next generation of metrology professionals. These companies and others like them have trained people in the use of their products for some time, for a long time. I mean, obviously, you manufacture a piece of equipment, you're going to get training in them. But now they are offering broader skills assessment and training to fill gaps in knowledge. We've talked about this, as you, all of you probably know. We're part of the media sponsor for the Coordinate Metrology Systems, the CMSC, with their level 1 and level 2 certification programs, and those are a step in the direction as well. So what we're really talking about is the metrology companies themselves are starting to offer basic metrology knowledge, not just how to use their equipment, but what are the basics of measurement. It's not just a matter of going up, pushing a button, and the instrument takes all the measurements for you and you don't have to know a thing. You need to understand the basics of measurement, and a lot of these companies now are offering those as part of their universities.
Well, I think what we're finding is that the knowledge, the bodies of knowledge are there, resident within the organizations, within a lot of the companies that you see at this show. They're here, the knowledge is here, and not that it's not there necessarily at vocational schools, trade schools, and universities, but I think that there is a competitive pressure to do it well within the framework of industry, right? I mean, it's about business. So it's always going to be better if the organizations, the companies themselves can provide that knowledge for what they really need to do. And that's, I think, what we're talking about here, what we're seeing at this show, what we've seen for a couple of years now.
Well, there's another aspect. You mentioned university. One of the problems with the traditional trade schools or universities that do offer measurement training is they suffer from a lag in their curricula. So they're getting their equipment, the equipment that maybe they're putting in their university lab, their test and measurement equipment that's being donated to their university lab, or maybe it's software, and the curricula is all based on something that might be 2-year-old technology. But these companies are cranking out new technology every 6 months, every year. So by the time they're getting students out of these trade schools, they still may not be up to speed with what the latest and greatest is in terms of measurement. And so that's actually another advantage of the companies offering this kind of training themselves. So.
Yep. And we saw something else really interesting, Dirk. We had a conversation yesterday at one of the booths here. This idea of software as a service and using the cloud, and it's really for manufacturers of all sizes. A lot of times I think that small manufacturers, job shops for instance, will say, well gosh, some of these technologies aren't for me, they're for the big boys, right? But what we heard and what we're hearing in more than one place is this idea that a lot of the technologies, especially the software technologies, are really kind of pushing down now. The pricing is getting to the point where it's really affordable for anybody really to use this stuff, right?
Well, that's actually the value of a cloud-based service. And one actually really interesting one we saw yesterday, we were at the Siemens booth, and noticed they had a cloud-based software as a service offering that provided condition monitoring and predictive maintenance for job shops. Now, if you don't know what that is, basically one of the big things with job shops, you got CNCs, a lot of things can go wrong over time. You start to get excessive vibration, maybe because there's something going on with the spindles or the motors or other things like that. And a lot of the bigger job shops know to monitor this, they know how to monitor it, those smaller job shops may not have a person whose full-time job is to be monitoring machines or to keep track of this information. So Siemens, for instance, can come in, attach sensors to the machines. The information from that sensor is uploaded over the internet. Again, we're talking Internet of Things. Uploaded to Siemens. Siemens, as a service, will monitor all of these, all the machinery on the shop floor. And it's, when I say relatively inexpensive, I don't want to pigeonhole them, but they did say that for a small job shop, we might be talking hundreds of dollars a month. Maybe. That's hundreds of dollars a month, maybe. To monitor all of your equipment, give you a heads up when something's going wrong, something that you might not be able to do right now. So this really is pushing this capability down to the mom and pop shops that might be able to do this.
Well, that's who's walking around. A lot of times what you see here is you see people of all sizes walking around the show, but a lot of times you see really small mom and pop type shops. And the idea that these technologies are available now for anyone, big and small, is really interesting. And that's, I think, another one of the trends that we're really seeing.
Yeah, and we're seeing this across the board. Obviously here at IMTS we see it with test and measurement, but also we've been seeing software as a service for enterprise quality management systems, a lot of the the traditional, let's say, software only type applications. So a lot of things opening up for smaller shops.
That's right, that's right. Well, another interesting thing that we've seen, the project that we've seen at IMTS this week, is something that we could hardly have missed because it's occurring at the booth right next to ours. I'm talking about the Dimensional Metrology Standards Consortium, which is a group that's working on pressing issues within industry interoperability as it relates to the transmission of quality data, measurement data in particular, as we've seen. The consortium quality information framework is designed to address that issue with a suite of standards enabling the seamless flow of information within computer-aided quality measurement systems. And several major providers of quality hardware and software systems are part of the consortium, including our host for this episode of Quality Digest Live, Nikon Metrology. We're right here. So, to help us understand better the DMSC's objectives, we're joined now by Ray Admire, who is a QA engineer with Lockheed Martin's PAC-3 missile program. Ray is also the treasurer of the DMSC, as well as the chair of the group's Quality Measurement Standards Committee. So, welcome, Ray.
Thank you, Mike.
How are you?
Yep.
So, let's start at the beginning. When did the DMSC come together and why? Give us a little bit of the history of the group.
Okay, so the DMSC has managed the DMS standards since its inception. It was originally managed by KMI, and the executive director of the DMSC retired from KMI. And so he came to the DMS Standards organization and said, we need a new home for the DMS standard and to continue its building and implementation. And so that's how the DMSC got going. And then in 2006, we had an interoperability summit at NIST, and from that, the architecture of the QIF was ultimately designed and developed, and we've continued to progress. And over the last 2 years, we now have 7 complementary standards that work all the way from the model-based definition, so your requirements, all the way through to SBC and analysis. So you get plans, you get results, you get rules, resources, all these things that go into a product. So where a DMS was really concentrating on only measurement from an automated system, more specifically CMMs and optical equipment, now the QIF pretty much looks at the whole infrastructure of a part, all the things you measure, whether it's X-ray or it could be anything. So all of your attribute or variable information that you verify for a first article inspection or a PPAP.
And well, it's all QIF quality information framework.
Correct.
Again.
Yeah,
right.
so let's back up a little bit and talk about just kind of the basics of the QIF or the quality information framework.
Sure.
From my understanding, the way that works is, let's say from a company point of view, you know, I manufacture stuff. I've got to send parts, or I got to make requests to my vendors to send me machined parts,
sure,
right? And I might send it to I might send one part to vendor A for some machined parts. I might send some stuff to vendor B or vendor C.
Right.
And so in the past, the problem has been I would have to create a separate set of specs and requirements and so forth for each vendor, depending upon what kind of equipment they had, right?
Correct. So each vendor would normally generate their own plan of how they're going to measure that. And so if I looked at an inspection report from vendor A, vendor B, or even in our internal house, those inspection results would look very different. You know, and that's the beauty of QIF. If I get a model that says this cylinder is cylinder 5, then that name convention stays with that all the way through all of your inspection, regardless of where it comes from.
So the way it works now then is I create, again, as the company who's making a part, I create a set of specs. These are the dimensions I need, this is the part I'm measuring, all the information. And if my vendors are supporting QIF, right, it doesn't matter which vendor I send it to, the inspection report I get back is going to be exactly the same. I'm going to, as far as I'm concerned, they could all be the same company.
Correct.
Yeah.
So this plan, we as a manufacturing company, we could actually generate a plan that all they would have to say is, okay, our resource has a rotary table and does scanning, and it's a fixed head, or mine has this other type of resources to measure with. And then other than that, your definition of your features and characteristics, none of that changes. Your datum structure doesn't change, and the location in the report, that feature name stays the same. And we've even demonstrated here with calipers measuring items, and still the plan knows that that's a cylinder. It's this diameter that I'm looking for.
So, I mean, I would imagine, obviously you have to get the various equipment manufacturers, let's say, you know, Hexagon, Zeiss, Nikon, all of these guys have to work together to kind of support the QIF, right?
Absolutely, and most of those are members of the Dmsc. They've been supporting standards.
Was that a hard sell, though? I mean, because people tend to like to use their own proprietary software, right? I mean, that's just the nature of the business.
Right.
You like that. So was that a hard sell to get everybody to kind of come on board with this?
Well, today we have 13 companies that are demonstrating with their software the QIF and how it works for them. And so it's been fairly low impact for them to implement because it's an XML base, and most of them have that. But the other side is we're not asking them to change their internal architecture. I mean, whatever made you good at what you do, we want you to continue to do that, right? I mean, everybody's in business for a reason. Each one of these companies, they have a business model and it's working for them because they're still in business. So what this allows them to do is to provide to their customers a non-proprietary solution of reporting and getting that information out of a CAD system. So where we haven't had the CAD plus the PMI downstream to our users, that's one of the things in the 2006 interoperability demo that we said was it's our biggest bottleneck. We don't get that information. That intelligent information allows our other system, all these systems, to be more intelligent.
So the upshot of all this is that for the company, for Caterpillar or Lockheed, John Deere, whoever, the value of this is that they can be confident that if they send their parts to be manufactured or to be machined to any vendor that has equipment that is support of QIF, they're going to get results back that are consistent. They're going to understand what they're getting every time. They're not going to have to internally translate an inspection report from one company and try to make sense of it for themselves, right? It actually just speeds the throughput and
right. So this should save a lot of money and a lot of time. So a large company that has 80-something% of their products are normally procured, I would say.
Right.
You could actually generate your requirements, give that to your suppliers, and get the same information back, and it's going to make them faster. They don't have to develop that measurement plan. We've helped them do that. So you can imagine where now you're waiting on them to give you that information, and that information may just be a non-intelligent PDF file that you look and say, okay, it looks like everything was good. This is red, yellow, green. I'm in tolerance. I'm at 80% of my tolerance. I need to go spend a little more time to get my data better.
And what is, just wrapping up now, what is the status of the standard now?
Okay, so we pushed the 2.0. We released it last Friday for open for the community to give information back to us on what works or what they don't think will work with it. So it's out for public review. Last year when we did the nucleus, the library, and the plans and the results, it flowed very seamless. We've added 4 new standards with the model-based definition, resources, rules, and statistics. And so we expect by December of this year, by Christmas time, we should have these 2.0 will be released and ready for the community. And again, we have 13 companies here today that are demoing at 10 and 2, and they're showing that we're ready for that.
Okay.
And where can people go for more information if they want to check it out online?
Absolutely. QIFstandards.org and Dmscstandards.com.
Yeah, I believe that we had a link actually below our player page right down there where people can go check
Absolutely.
that out as well. So you can go online and do that.
Well, Ray Admire, appreciate it. Thanks for
Thank
doing us
you.
at the
Great
event.
seeing you.
I appreciate it.
Okay, no problem.
There it is, Ray Admire of the Dmsc, talking about the Quality Information Framework. Really good story there, and we'll continue to follow that. And again, check it out online. Again, link right below the player page, right down there. Okay, well, we're going to turn to another story now because, you know, Dirk, when you're here at IMTS all week, it's hard to remember that there's actually things going on around the world outside of McCormick Place. It becomes this insular world where it's like nothing exists outside these walls. But there are, in fact, things going on outside the world. The people of Scotland, in fact, are going to be going to the polls exactly a week from today.
That's right.
To decide if they want to remain part of the United Kingdom or go their own way independently. So what, you may ask, does that have to do with quality? Well, for the answer to that question, all you need to know is that longtime QD columnist Paul Naismith is, well,
Scottish.
Gee, that was easy.
Yes.
So Paul's article, What Will Scottish Independence Mean for Quality?, ran in Quality Digest Daily on Monday. In it, Paul examines the question of Scottish independence and how that decision could affect change and engender improvements that will be great and far-reaching. But first, as we many times do with Paul,
yes,
we get a little bit of a left turn. We get a history lesson. I'm a history buff, but I did not know, I discovered in the article, that in 1698, the Scots were the first Europeans to colonize and attempt to develop trade both to the east and the west along the Isthmus of Panama near the Bay of Darien. The colony, maybe because we don't know about it now, was a horrific failure, and the financial ruin of the Scottish government led almost directly to the official union between Scotland and England just a few years later in 1707, and the two nations have been together ever since, but maybe not for much longer. So that quality failure led to the initial bonding together of England and Scotland.
Exactly. Yep.
And now they're looking at maybe breaking that union apart.
That's
now,
right. This has been coming for a long time.
More than 400 years later, right? So as the article points out, the new Scotland shouldn't be voted into existence as an independent nation, will need vision for change and improvement. The leaders of the independent movement have laid out a substantial part of this vision in a 670-page document, which I think Paul read the entire way because he mentions that the term quality repeatedly appears throughout the pages, and although supporting details on how that quality actually connects to the government are a little sketchy.
It's from politicians.
It's from politicians. It appears that those people behind that, the politicians, the technocrats, and the like, those people behind the Scottish independence movement are at least aware of the need to use the precepts of quality improvement in leading the nation. They talk the talk is what I'm saying here, what Paul is saying. They kind of understand that things like quality of service and delivering, listening to your customers, your residents of Scotland, is important to doing that, to leading good government.
And we see this obviously more and more in government. It is interesting. The word quality and stuff like that, where you never would have heard those kind of terms before, now pretty much common parlance in political speak.
Well, and we do, and we see it as well. We saw, campaigns being talking about Six Sigma, using Six Sigma.
Exactly. Newt Gingrich was trying to do something
about
that.
And we've seen increasingly, like the Baldrige, for instance, will be won by city management. Will win a Baldrige award. So obviously, these ideas are penetrating to the heart of it. So whether or not, if the Scots vote for independence or not, it's interesting, I think, to see that what we do for a living is embraced in these different fields. And I think that it's not necessarily close to manufacturing, test and measurement, standards, but whatever. But I mean, those of us that understand the history of quality and the reasons why anyone would want to improve anything, understand the importance for doing things in a certain way in that process. But I think others are starting to get that drift as well. And I think that's to me what I took away from that article is that the language of quality, the improvement, it's really for everyone. It's for everyone, it's for everything. And it's good for Scotland, it's good for their people, and it's pretty much good for everything regardless of what happens with this vote next week.
That's right, next week, September 18th.
September 18th, a week from today, they're going to be doing the vote. So we'll be having our eyes peeled for that. I'm sure that Paul will be following up, as he always does, to give us more information on that going forward.
Exactly.
All right. Well, we're going to turn now, Dirk, and I know you're going to run because we're going to turn now to our tech corner, which is a really good tech corner that we have this week coming up for you. Dirk is actually going to be scooting over there. We're in the Nikon Metrology booth, of course, here at IMTS, and we're going to be looking at a very interesting product, the P3D portable measuring system, and Dirk is going to be looking at it right now with the Nikon folks, so take it away.
Okay, we're over here at one of the booths here at the Nikon booth, one of their setups here at the Nikon booth, to look at the P3D, I believe, and with me is Dennis Finn. Dennis, thanks for letting us come over. I realize you got a lot of customers. We're kind of barging down here, but I appreciate you taking the time.
Thank you, Dirk.
What are we looking at here?
It's a new portable 3D scanning system from Nikon. Allows you to take a 3D point cloud to a 300 micron accuracy and generate that point cloud. You can manipulate it in your CAD database or with the P3D viewer that's available as well.
And can I pick this up?
You can. It's completely portable. It does have the cable attached to it.
So we've got a little tripod on here, but you can hand hold this, right?
You can. You can unplug it. This is just the AC here, so we don't run the battery down.
Okay. So we've got a couple of hand holds here. So minus the tripod, you could just hold this, and well, I'm holding it the wrong direction, obviously, but okay, interesting. So this is the technology is what? Fringe?
It's a Fringe projection method. Okay. It's a newly developed Nikon laser diode system there.
Okay. And how does it actually work? I think you have a...
Well, you can't see it here, but it projects a fringe on there, and it's looking for deformities in that fringe. And that projects into an X, Y, Z so that you can generate your point cloud.
Okay, and if I can just look at the front of this a little bit, I kind of like pointing out people how some of this stuff works. So you've got, on the front of this, you've got what, a projector?
This is your camera system here. So this is going to pick up your scan data.
Okay.
And this is your scanner right here.
So you're projecting out of here, and then the camera is picking up
collecting the data.
Is collecting the data.
That's correct.
And you said an accuracy of 300 microns. 300
microns, that's correct. And there's also a camera that you have in here for capturing 2D data. That's a nice feature that you can project that picture onto your 3D data to get color.
Explain that again. So how's that working?
It will project. I'll show you a little bit later.
Yeah, okay.
Yeah.
All right. So so kind of give us the demo here.
Okay. Completely portable. You have the ability to capture your data on an SD card. If you have a Wi-Fi enabled SD device, that will send that information straight to your PC.
Okay.
Also a USB ports and digital video as well if you want to project this onto a larger monitor.
Okay.
As we say, completely portable. You have 40 minutes of lifetime with the battery that comes in the system. And if you wouldn't mind to pick up the portable battery pack there for me.
Okay.
You have 4 hours of battery life if you use the extra battery pack.
And this just what?
Just plugs in.
Just cables in.
Yeah, just cables in.
Okay, got it.
Okay, so we'll move to here as far as the functionality of the system. When you put your part in there, you want to set the exposure. So you'd focus. Let me show you on here as well first. So you have the laser diodes here, and what you want to do is place that at the optimal focus point. It has it has a 290 millimeter offset, and you have a focus depth of about 100 millimeters.
Okay.
So get it into optimal focus position, and then you would just push the button to set the exposure. I'll show you that here as well.
Okay.
I just can't adjust this up and down.
Okay, gotcha.
So you same thing. You set the exposure.
And by exposure, we mean the reflectance at where the laser dots are at?
That's correct.
Okay.
And so it'll automatically adjust the exposure, and at that point what you can do is just capture your point cloud. It's going to take a few seconds to capture.
Okay. Now, while it's capturing that data, so this is handheld, but as long as you hold it reasonably steady.
Reasonably steady, you'll get good data.
Okay.
It would probably be recommended to use it on a tripod or something like that, or maybe a single monopod, just to keep it more stable.
Okay. And that's their scan data right there.
So yeah, you see it was very quick collecting the data. At this point, you can manipulate this data. You can expand it, contract it. You can rotate. You can manipulate the data how that you want to. If you get it into a orientation that you don't like, you can always hit the return button, and that'll take it back to where the scan data was initially captured.
Okay. Now I notice we've got some shadows here, so obviously you could take multiple angles, right?
That is correct, and we can go over that a little bit later.
Okay.
Yeah. So if you want to shift your data, just 2 fingers and rotate, or shift it, and you can do measurements on this device as well.
Okay.
So we'll go to the tool menu here. And there's a number of tools here that you have to do measurements. So we'll just do some simple ones here. We have a point-to-point, so I can just pick out a point to this point here, and it gets your measurement here. And I can move this fly out wherever I may want to.
Okay.
To keep it out of the way. We'll do one more measurement here, maybe a plane measurement, and I'll just pick out this location right here. So we've constructed a plane from that data as well.
Okay. So. It's usually either drawing a box around the feature that you want to measure or touching individual points. Is that the
correct.
Interface? Okay.
And I can use my finger. It's just a little bit easier to use the stylus.
Okay. And kind of standard measurements, straight line, radius, cylinders, that sort of thing?
At the current moment, you see a point-to-point, plane, plane-to-plane distance, sphere-to-sphere distance, cylinders, cylinder-to-cylinder, and cross-section. So if we just select cross-section, we can draw across the part, and there we have our cross-section.
Okay.
Where'd my data go? I'll just reset.
There we go. Okay. Ah, terrific. Interesting. Okay. And you were saying, were you going to show like maybe being able to stitch together multiple?
Doing the overlay of the 2D image over it?
Yeah.
So what we'll go back is, just go back here to the folder list, and I have a piece of data saved. It just shows a Pikachu, and it will show you the overlay of the 2D image over the 3D point cloud. So I've captured that 2D image of Pikachu that you saw there, and this right here is that image overlaid on the 3D data.
Wow. Okay.
And the same rules apply here. I can manipulate the data how I want to, go back to the original orientation if I choose to.
So point cloud data, how is it output? What formats can you output it?
You can do STL, PLY, and ASCII formats.
Okay. Now, I think we were talking, obviously in that first shot that you had there, you did one shot over the top, so there's some shadows. So if you were trying to get all angles, you could just keep taking multiple shots and it would combine them all together?
That's correct, and that's where I would use the targets here.
Okay.
So I'm just going to grab these. So if in that case, if you want to take a complete 3-dimensional image of this, I would use this turntable since this is a small part and it has the targets on here to keep my datums in place. So I can take 5 different shots and take an image and rotate it, and it keeps these in the coordinate system so that it knows where it is in space. Okay. And just 5 discrete positions, and you can reconstruct that data, and that's what we have right there is the 3D print of that point cloud.
So you went directly from you did your scan, you'd output it to STL.
Yep.
Took it to a 3D printer.
That's correct.
And printed out.
And that's the result right there.
Wow. And 300 microns.
Yes.
That's nice. Okay, well, appreciate it. Dennis, thanks for showing us the P3D, right?
P3D.
The portable 3D
metrology scanner.
Scanner from Nikon.
Yes.
All right, well, back to you, Mike.
Thank you.
Dirk Ducharme to look at Nikon Metrology's new P3D portable measuring system. That's this week's Tech Corner live from IMTS. That was fun, Dirk.
That was a long ways over there.
That was more than your normal 100 micron journey to do a Tech Corner, but it was fun. That was a great job. Great job done by you and Dennis. Thank you for doing that. Again, that's the P3D portable measuring system from Nikon Metrology, and for more information you can find it online at www.nikonmetrology.com. Okay, well that's our show for this week, but before we go, we'd like to offer thanks to our sponsor again, Nikon Metrology, right back here. The host for this episode of Quality Digest Live, and today's sponsor. Nikon Metrology offers the broadest range of metrology solutions for applications ranging from miniature electronics to the largest aircraft. Nikon Metrology's innovative measuring and precision instruments contribute to a high-performance design through a manufacturing process that allows manufacturers to deliver quality products in a shorter time. For more information, again, just click on the banner area just below or just to the right of this video player screen, or visit nikonmetrology.com right back there. Okay.
There you go. Okay, well, that's our show for today, live from IMTS at the McCormick Center in Chicago. And we thank all of you for joining us. Hopefully you watched all our shows here. We did a couple of other Technology Lives from some other vendors here at the show.
That's
it was
right.
Really fun. A lot of good information here at the show. So once again, thanks for joining us, and we will see you.
Thank you to Ray Admire as well, of course, for joining us. Ray joined us. And yeah, we'll be seeing you next week back in Chico, back in Northern California at our normal studio for Quality Digest Live next week, of course, on Monday for another great week of Quality Digest Daily. So join us then, and safe travels, everybody coming back from here. We'll see you next week.
So long.
Bye.